Thank you everyone to come here today to IOActive Lab. It's my first time here, so hope you will enjoy this research and you will learn something new today. I post here a short video on how we are going to do, and probably someone here do some radio stuff before or something related with radio. So perfect. Yeah. Perfect. So okay, we have a car here and an evil hacker doing some stuff. As you can see, we are using the key fob to open and close the car multiple times. I don't know if we have shown. Okay, don't worry. We can check. Whoop. The car is. We check we open and close the car multiple times, and finally we check the car is closed. So the key is on the top of the car. I'm replying some signals. We have the capability to open the car without the key fob. So this is what we are going to talk today. I hope you will enjoy. We have here the agenda. We are going to talk a little bit more about me. We have some fundamental prior language about the radio, because it's really important to understand how the roll jump and rollback works. Then we have the newest scenarios that you can perform these attacks, and then we have questions and everything you need. I will be here. Please be careful, because in some countries like Spain, doing jamming or these kind of techniques are so illegal, and you can get in trouble very easy. So if you want to perform this type of research, do in a control area and the permission with the owners of the cars. I'm an Associate Security Consultant at IOActive. I have been working in cybersecurity for 2 years. Here it's my 3rd month. I'm almost a software engineer. I have 23 years old, and tomorrow I have my last exam. It's kind of funny. I love cars and the red team walls, like malware and this kind of stuff. I love it. We need to perform these tasks. We need to understand how the radio works, at least the basics, because it's a deeply topic and you can't be so much technical here. But the first question that I had when I started doing the research is which kind of devices we need to use. And because, okay, we of course need the laptop and all the videos and all the stuff that's on the internet. We saw the laptop, the key fob, and the car. But we need more devices like the radio to transmit and receive the signals. We have 2 types of radio, the traditional ones, that they are composed exclusive by hardware parts, so all the work and the operation that this kind of devices is performing by the hardware. And we have the SDR, or software-defined radio, that it's a radio, but the communication and the components has been traditionally implemented in the hardwares, are instead implemented by software parts. And so this type of radio have the ability to modulate and demodulate signals with some software on the laptop. And this is the radio that we are going to use to perform this kind of research. And at this point, I realized, okay, I need an SDR, but which I should buy or which SDR I need to use. And whoop, it's black screen. Okay. The real question is, okay, what kind of research I want to do? Because we have a bunch of different SDR on the market, and you have SDR from $30, from $1,000 and $1,000. We have different types. The more simple one are the ones that can have the capability to receive signals, just receipts. You can buy it from $30, depends on the country or where you are. You have the ones that can transmit and receive signals. Okay, think like most of you knows about HackerWeb. We have the Jarested one. It's a really good one. And for Bluetooth stuff, we have the Ubertooth. Like most of the Tesla stuff is performed with this kind of devices. Then we have a more complex one, like BlackHat, and for professional uses, like USPR. But here at IOActive, we have some of them on Madrid. But for this kind of research, we just need like some basic stuff with HackerWeb or Agnostic, and we don't really need to use like the professional ones or BlackHat, something like that. Another point, like, let's be careful. For sure, here on Spain it's jamming it's so illegal, and if the police know that you are doing that, you can get in trouble very easy. So please be careful. Another point that is basic here is, okay, when we are opening the car, that most of you, at least I use the key fob, and it's a remote key entry system that when we are pressing the button, we are sending signals, and these signals is communicating with the car and do this stuff. Depends of where the car were built. You have two different frequencies. European, Asian, and British has the 433 signals, and the American and Japanese car works on 315. The key fobs can do this like lock, unlock the doors, turn off, turn on the vehicle, and it's built with his own cipher, with chip with cipher. So it's a really interesting hardware part that you need to look at when you are doing this research. But the important here is how the signal or the process that the signals perform when it's transmitted on a distance. And modulation is the process of modifying like an information signal so it can be transmitted over a channel. And this signal contains the infos, like when we are hearing Spotify, radio, this kind of stuff. Before that, need to be like on that kind of process. We have two different modulations. We have the analog one with the radio that everyone here knows about it. And then we have the digital modulation that the key fobs use. In deep, there's just 1 or 0 that the car is going to use to perform the action. So this is it. And it's important to know that the modulation that has been used in automotive world, we can divide in 3 categories: the AC key, or amplitude shift keying, frequency shift keying, phase shift keying. Also, these groups have its own variation. We don't really need to know how this works. We just need to know, like, we have 3 different types, and depends of the car or the manufacturer that you are testing is going to use one of them. And we here like an example of AC key signal with the spectrum analyzer, and then a variation of FC key, and the number 2 is because he refers to the number of tones that he used. And in the middle here, we can see like a small line is the frequency deviation, that is the way to describe between the minimum and maximum extent of frequency. And just that, we don't really know more knowledge about this kind of stuff because it's not necessary for this kind of attacks. And okay, that's part. It's really important because the rolling code. It's really important to know why we can perform in our days like a simple replay attack on the automotive world. We have here how the ECU works. I think that everyone knows how it works. When you press the button to close the car open or close, depends of the button you press. And here we have the fixed code that the cars used like 20 years ago, something like that. And if we put the video, we can see that use simple codes, and every time that we press the button, it's generating a code. And this type of code work on white basics. So when the key fob when you use the key fob, it's transmitting a code. And the car has like a dictionary. If the code is in the dictionary, it's going to perform the action that it's supposed to perform, and if not, it's going to reject the code. And as you can imagine, this kind of codes was really vulnerable to replay attacks, and this is why the rolling codes implemented in our days. We have here the difference about the rolling codes and fixed code. As you can see, like every time we press the button, a random code is generated. So it's supposed to be more difficult to do this kind of attacks. But another feature that this code has is this code is a single code use. Once the car has received the code, cannot be used again. So it's protected for the replay attacks. And I put here a small diagram of how it works. We have the fixed code, we apply a random hash, and then we have the rolling codes. This is how I usually approach when I need to analyze a key fob or something similar with radio. We have 12 different codes here. The hardware part, it's really important to know which chip codec is working. In this case, was the 4D70. Then we need to identify which modulation is using. As you can see here is the AC key. Most of the program nowadays do, and you don't need to understand how it works. So it's easy in this way. And we have the bit level. As you can see here, like when the line is on the ground, it corresponds like a 0, and when he was up, it's 1. So it's not using a bit codification in this case. And this is how the rolling codes seems like. It's awful, but you can see here, like every line, it's a different signal, and it's completely random. At least it's supposed to be random. So with this knowledge, we can go with the first big attack on car war. It was the roll jump. This attack was presented by Sami Kankar at DEFCON 23 in Las Vegas, which was basically allowed to circumvent the security measure that the manufacturer imposed with the rolling codes. And I put here a small diagram of how this attack works. We have the owner, we have the vehicle, we have an evil hacker on one side and a jamming device between the owner and the vehicle. And when everyone wants to open the door, he's pressing the key, he's sending an unlock code, but the hacker has the rollman device working, so the car is not going to receive the code, and the vehicle is still locking. A human reaction here is to press the button one more time, because when you are pressing the key and the car is not open and you want to go inside, you need to press another time. But the jamming device is still working, so the car is not going to receive the code, and the hacker is capturing the second code. At this point, in a real scenario, the hacker needs to have the ability to capture at the same time the codes, and when he is capturing the second code, he needs to send at the same time like the first code that he captured, because and perform the action. That in this case is unlocking the door. And then the hacker has one unused code that is a rolling code. So the car will be, if the hacker transmits the code, the car is going to be open. Then the owner locked the car. He don't use the key more, and the hacker has like a one valid code that the car didn't receive, and is going to open the car. It's really basic, in deep, and this is the methodology that I usually follow. And this is how I test the attack in a controlled environment, of course. We have a jammer device here and a hopping program that permit me to jump between signals. You can see here like 4339 and another signal to receive the codes. And we have here the best program in the world, software program. It's GNU. It's for me, it's horrible. It was my first time with this kind of software. Like, it's really powerful, but it's not friendly for new user. And I put a small video here that we are up with a unpublished jammer. You can see here that it's working on the frequency of the key fobs. And then we have another file that is going up the hopping program, and just is jumping between frequencies to be more easy to test this kind of attacks in a control area. And now, if the Mac works, perfect. We have the business, the real business in nowadays, like is the rollback. This is a time agnostic attack with is going to perform a resynchronization of the internal clock of the key fob on the car, and it's a replay attack. The original disclosure of this attack was presented to BlackHat 1 year ago, and they wrote a perfect paper that you can see like all the tests that they perform. And of course, we have here a demo. As you can see on the laptop, we have a laptop, we have the SDR on the right side, and a bunch of signals in the middle of the screen. So we don't have audio, but I pull the door and it's closed, and when we transmit some signal, we have the ability to open the car without the key fob. And now we are going to know how this works. We have the same scenario than later. We have the owner, we have the vehicle, we have the jamming device, the hacker, and I put here two more emojis. What is the key fob counter and the cap counter? Both of them start paired, so are both on 0. And then, okay, when the owner is going to want to open the car, like later, the hacker has the jamming device and the car is not going to open. But as you can see here, the key fob counter, because we press it one time, the bottom is going to increase by 1, but the car counter is still on 0. It's really important to understand that, because this kind of attacks are a resynchronization about these counters. It's just that. So the hacker captured the first signal as the owner transmits, and then he's going to press another time the button. The jamming device is still running. The key fob counter, it's increased by 1, and the car counter, because the car didn't receive the signal, is still on 0. He do another time. The key fob counter increased by 1 is 3, and the car counter is 0. It's synchronized, and the car at this point is still locked. But now, like the hacker is going to stop the jamming device, the owner is going to transmit a 4-time code, and the vehicle is going to receive, so it's going to lock, and both counters are going to resynchronize. the owner can use the vehicle as usual, and the hacker is now have 3 sequences codes. In this case, it's not need to be sequences, but it will show in the future. But this is agnostic because if we want to perform these attacks, we can grab the signal on May and then replay this signal on December, and it is going to still working. This is the key of the attack and how powerful it can be, because at the moment that the hacker found a bunch of signals, then when you transmit these signals, like as we can see here, these 3 signals are going to resynchronize the internal clock of the car, and it's permit to perform the action of the threat signal, and he's going to have a new car and go home with a Porsche. But if something that I didn't understand at the beginning is why on the videos that you saw on the internet that they perform the attack, they didn't have a jamming device or something like that, and it's because to perform this kind of attacks, it's not necessary to do the jamming part. So you just need to grab codes, valid codes that the car can receive, and then if these valid codes, not the codes like the key fob and the car, are vulnerable for rollback, they are going to work. They don't really need to jam in anything and do this illegal part of the attack. Of course, like if you want to steal a car, it's still illegal. And okay, like as we know, like rollback is different than rolljam, because on rolljam we are evading like the rolling codes, and rollback is just a resynchronization. These attacks perform with 2 or 3 valid codes. We don't need more. So if we found 2 valid codes that resynchronize the internal clock, is going to work. We don't need to jam any signals, and the owner can use the vehicle as usual and didn't know that it's a hacker around them. This is the original vehicles that they disclosure at BlackHat, Kia, Hyundai, Mazda, Nissan, and Toyota. And I can put like the vehicles that I found because the manufacturer didn't answer my emails. So I just put the years of was built. As you can see, modern cars still affected. And this is a real scenario that I perform the rollback. We have 5 used codes that is using it's using a rolling code. So if you, in an intended way, when you reply one of these codes, is not going to be affected by the car, but the 2 first code is going to be the ones that do the resynchronization part, and the next code that we send, he is going to roll back all the counter to this state and is going to perform this signal like valid, and in this case the car is going to open. This is the sequential part, but this attack can perform with intercalate signals. As you can see, we have the 5 signals as before. The red one is we used it before, and now we are going to use the blue one, the 2, 4, and 5. If we reply 2 and 4, these 2 signals are going to resynchronize the internal clock of the car. On the 5th one is going to be open. So it's increased the criticality of the attack because you don't really need to capture sequence signal. You can perform this attack on different ways, like intercalate and this kind of stuff. And now we have, okay, what is new here? What is the newest scenarios that we can perform these attacks, and why this is more powerful than we thought in 1 year ago? When I mastered and understood everything of the attack, I asked myself 2 questions. So it is possible to carry out like the rollback in different days, and with how many codes it's going to work? Because if we grab in different days, we can perform these attacks with a bunch of theory codes. And that's the new thing. I perform the rollbacks grabbing codes from different days. It don't need to be in the same day or in sequences. And perform the rollback on a round of 50 old code. So it's still more powerful than we thought. We refresh a little bit. We don't need jamming to do this kind of attacks. Okay. Signals don't need to be sequential. In some cases, it depends on the car, on the manufacturer, but in some cases that need to be strictly sequential. So this scenario won't work. And why it's not working? Signal persists over the time. That's why it's agnostic. And you can transmit loose, strict with time frames. Depends of the case. So we have here a bag of 20 old codes that, as you can see, it's a different kind of signals with another modulation and this kind of stuff. But these codes were captured on 5 different days. And so I just put the hardware with portal pack on the car, just grabbing signals when I close to the car, and with 5 days of ramming, and then I execute the attack with the 1, 7, and 19 signals, and the counter of the car is going to roll back at this point. So imagine if you are using your car and you have a jamming device, you have a device under your car that it's only grabbing codes, and then when the hacker wants, he can grab the device, analyze the codes, and in the future, when you don't know and you didn't notice anything about him, he replaced some of these codes and stole the car, and you didn't know what is happening with your car. And this is why the manufacturer have taken actions and have started to fix this type of vulnerabilities, because it's really easy to fix. But of course we have the failed versions, because I failed it too many times. And during the days of testing, I noticed some specific stuff that we can see here very easy. And at the moment that I use the 1, 7, and 14 signal, the car with the same code, the car won't open. But why is this happen? So if this works, I decide to crop an old signal here, if someone don't know. But I crop some of the signal, and I notice a shift of the peak on the signals, as you can see here, the yellow part. And if you do a bit analysis, you can find a pattern just in this peak, and came to the conclusion that it's right at this peak that where the specific bits were sent for the execution, unlock or lock the door. So in this particular case, the rollback, well, before that, we can see here on the odd signals, we have the peak on the left side, and on the right signal, the peak is on the right side. So it's a pattern, and when something is a pattern, you're probably going to find something there. And in this particular case, the rollback only performed with odd signal with odd signal, and even with even. So if you, at the moment that you transmit odd with even, it's not going to work. And the new scenario that we have here, it's going to be about timing. We have 3 different signals. As you can see here, we have 3 different signals with a time frame of 1.5 seconds each signal. So it's they said on the original paper that in some manufacturers you need to have like a strictly time frame between signals, and as you can say that the time is imposed between them, otherwise the attack will fail. So at this point, if you transmit these 3 signals, the car is going to resynchronize at the 3rd one, and is going to be in the lock phase. So that's probably you thinking, okay, if they already say that, what is new here, and what is the power for this scenario? This signal were captured on 4 different days, and the important here is I performed the attack with a bag of 50 different codes. So at the moment that you notice that this is the first, this is the 26th, and this is the 5th signals that we managed to perform the attack. And here, hacked. You have the same demo as before, as you can understand now better now. Every time that we press the button, the button, it's all code that is supposed to be invalid if we transmit. And then at the moment that we transmit the 3 codes, the car will open. We have here another video that you can see a little bit that you have a specific time frame between signals. And let's check that the car is closed. Yeah, I'm on the parking of my university. And yeah, it's supposed to be with sound, but now the car, it's open. This is the new finding, like model vehicle is still affected. The last vehicle was built on 2022. Jamming is not necessary. Some of the it's a design flaw in some manufacturers that it can be removing with a good control of some stuff or with software or firmware updates. It's more powerful than we thought because we don't need to interact with the owner and we can perform for weeks. And it depends on the code hopping, not on the days hopping. That means that if you are using your car in one month 50 times and you press the button like 50 times, it's going to work if these valid sequences resynchronize the internal clock. And of course, we like to open and we like to hack, but we need to know how to mitigate or how to be secure the car here. It's really important to the manufacturers to implement a good control about the old codes. They need to discard and they need to find another ways to resynchronize the key if something is not working on the key fob. Mandatory physical resynchronization. I know that is a little bit tricky here, but it's sometimes the old things works, and in this case, is the most security measure that we have. Measure for jamming-based attacks and establish like anti-jamming technology on the cars. Of course, this is very expensive and it depends on the car that you are using or you are buying, it's going to have or not. And yeah, when I started, I didn't have any methodology because I didn't know about radio. I didn't know anything about this world. I just like cars and hacking, but I didn't know anything about radio. I didn't have any indications. And of course, if the manufacturer didn't answer my emails, about, okay, your car is it's vulnerable to these attacks. They didn't bring me off the official documentation about the firmware or something like that. And the way that I approach it's to read many posts as possible, see video, see anything that you can find on the internet to try to understand in a high level how this can work. Then read a lot of code from any repository that you can find on the internet, and trial and error. I don't know how many times and how many hours I spent on my garage trying to open my own car, but I believe that it's very important to fail, because you learn much more from failure and unsuccessful tests than when everything is handed to you working and all you have to do is to execute the code, in this case the signals, and that someone provides to you. And that's all. Thanks for being here. I hope like you understand me and my perfect English. You learn something new today.